Hey, I'm Cameron Makenzie, and I want to show you how to fix the top 10 most common runtime exceptions in Java. Runtime error number 1. This is the good old arithmetic exception that'll happen if you ever start dividing by 0. And you can see here we've got int y equals 0, and then we're dividing by 0 here. That's going to cause a problem. So, you can always just do a little check. You can always say surround with an if statement and check that, hey, if y is not equal to 0, don't do any division. And all of a sudden, if I run this application right now, boom, I don't get any errors. I don't get any output, but I don't get a runtime exception. So that's the arithmetic exception. Let's take a look at this here. Oh, I think we're setting things up for a null pointer exception. Go to a null pointer exception there. Now that's caused because we've got an object initialized to null, and then we try and call a method on it. You can't call a method on something that's null. You can't get a property of something that's null. A null thing is null. So what do you do here? Well, you can always do the null check. I'm not a big fan of the null check, but sometimes it's required. So you can say if data is not equal to null, that'll make the problem go away. So if I now try and run as a Java application, you'll see there's no error. There's also no output. It might be better to A, B, C, D, E, F, U, and it might be better to just actually initialize the variable, for goodness sakes, then it's not null. And there you go. We get the length of that data. So that's how you can get rid of that null pointer exception. Now, where are we going now? Oh, I thought this was going to have to do with the date time exception, but no, this is a cast exception. We're trying to figure out who the actors in our play are going to be, and they don't like the cast here. You can see right here, ClassCastException. So we've got this class called timestamp. We've got this class called day. Class called date. I do believe that if I looked at timestamp, it would say timestamp extends date. So timestamp is a type of date. However, polymorphism in Java is unidirectional. So although a timestamp is a special type of date, a date is not a timestamp, just like a Mercedes is a car, but not every car is a Mercedes. So we create a date, we try and cast that date into a timestamp, and it says, no, you can't do that. You can't cast down the tree. So when we run this, yes, it doesn't like who we're casting in our play here. We get a ClassCastException. But how do you avoid that? Well, don't do casting. We could maybe make this a date object, right? That might be one way to get rid of it. So just do things properly. But I think one other thing that might actually be kind of interesting is we could probably flip this around. So if we did timestamp time equals, how do we create a new timestamp? So we need to create a new timestamp. System.currentTimeMilli is all we need. Okay, so we create a timestamp. So we've got the timestamp first. The timestamp is a type of date. And then we want to get the date today. We can actually do the cast here. And so this will actually work. So we can say date time. And now, since the date is a type of time, that cast will actually work. So watch, if I run this now, we actually get the date. So there you go. A little bit on the unidirectional polymorphism of Java. Okay, and I think I mentioned a date time exception might be coming up, and here it is. If I run this code, boy, look at that. Date time format, runtime exception right there. Unsupported temporal type. We'll actually take a little bit of a look at that unsupported temporal type. You'll actually end up finding out that's actually a special subclass of the date time exception. And why are we getting that? Well, we're getting that because it looks like my system doesn't support the RFC date time. But there's a bunch of different date times. Why don't you just get an ISO date? Right? Use a data type that your application supports. We run that, and I don't know what this kind of nonsense is down there. That's not supposed to be there. That's for a future exception. And anyways, you can see that when we use a supported time format, well, all those problems go away. So that's how you get rid of that date time exception. Okay, what's happening here? Oh, look, we've got an array with 5 elements. We all know what's going to happen here. Boom, we get an array index out of bounds exception. Now, the array is created with 5 elements, but it uses zero-based counting. So even if I use index 5 there, I'll still get an array index out of bounds exception. The last index in an array that has a size of 5, the last element is actually element number 4. So only if I make data at 4 there will it be within the range. You know, how do you avoid that? I don't know. Maybe use a collection class like a list, because a list can expand dynamically. You know, optionally, maybe just surround this with a little if statement, and you could always check that, you know, if the index is going to be less than 5, so int index equals 6, and then if index is less than 5, then change the item at that index. So there we go. This code looks a little bit safer right now. And there we go. We don't get the exception. But that key is that, yeah, you can't set an element at an index greater than the size of the array. So be careful there. What else have we got? Run this as a little Java application, see what happens. I think I know what's happening here. Negative array size exception. You can't have a negative array. You got to stick with the whole integer numbers. You can't have an array that is the square root of -2 or something like that. So that was the problem. That was negative. If you just make that positive, then why not be positive? We should all be more positive. There you go. The error goes away. It runs without a runtime exception. Now let's take a look at this one. This one actually looks pretty interesting. We've got an array of numbers, create an array of numbers of type big int. And if we actually look at big int, you'll actually see that big int extends number. It is a type of number. And so this is all valid here. And then we say, okay, well, let's throw in a double, right? And if I take a look at that double class, you'll see that double extends number. So a double is a number. But when I actually run this code, boom, array store exception. And even though this is an array of numbers, well, we actually created as an array of big integers. And we then try and put a double into it. And even though this says it holds numbers, under the covers, it can only accept big integers. So how do we change that? Well, I guess we could always just set element 0 to be a big int. So let's copy that. Paste it in there instead of double. Got to use the new keyword. And then when we run this, there we go. That error goes away. And of course, you actually have to call the constructor properly here. And how do you create a big integer? Okay, big integer, 1, 2, 3, 4, 5. There we go. Okay, now we got a big integer at that element, and everything will run fine. So you can see this runs without throwing an exception. You know, another approach like this might be just to make that number, right? And if we make that a new number, then, you know, we could do double dot value of. What do we have? 1, 2, 3, 4, 5 before. And now when we run it, it'll actually work because this is actually an element, an array of number objects, not big ints. So there you go, a couple approaches to fixing that particular error. Okay, what have we got here? Oh, I got an array. You know, I asked my boss for arrays the other day, and he said, no, just use a list instead. We've got a list right there of integers. So we've taken this array, we've used the arrays as list method, and we've returned it as a list, which is a little easier to work with. And then we try and add a new integer to this list, which will usually work. But in this case, we get unsupported operation exception. And that's because, well, boom, over here, that add method won't work because when you get a list from the asList method, well, that particular method is read-only. So you can't add to a read-only list. So how do you fix this? Well, you get rid of that add. If you want to do some manipulation to that data list beforehand. And then after you've manipulated the data list beforehand, so we can put 1010 up there, do that first, and then use the asList method. So you don't have to manipulate the list after you get it from that arrays class. Okay, over here, looks like we have a hash set created. Then we ask to get the next element in the array. Okay, that looks like it's going to fail. So let's run that. And you see no such element exception. And so here we create a hash set, but there's nothing in it. And so we say, hey, get the iterator for the set and then get me the next element. And the Java virtual machine says, well, there's no elements in it, so you can't get the next one. That causes an exception. So that's a little bit of an annoyance. Sometimes you might create a set and expect it to have things in it, and it doesn't, and all of a sudden you're getting an exception. It's not even that the hash set's null. It's non-null, but it's empty. And so how can you get rid of this particular error? Well, you can see the code down here already. It says check to see if it's empty. And so check to see if your hash set is empty before you get the next element. And if it's not empty, then call next. And if it is empty, well, don't manipulate it. So running this code here makes that error go away. And look, here's the last one. I thought there were 10, but I can see that RuntimeException 09. That's kind of weird. And what do we have here? I think this runs a long counter with the arrays unsupported exception earlier, except this is a concurrent modification exception. You can see that we've got, well, we created a list, we added an element to it, we decided to iterate through the list. There is something in it, so iterating through the list isn't a problem, so we can call iterator.next and do something with it. But you notice in here, they get that list, servers, and they try to add to it while they're iterating over it. And you can't do that. If you are iterating over a list using the iterator, you cannot manipulate the underlying list holding the elements. And that's what's happening here. They're trying to add Jetty to that list of application servers to complement Tomcat. You can't do that. You could do that afterwards. I could throw that down there, run the application, and the error goes away, but you can't do it inside of that iterator. Otherwise, you get that concurrent modification exception. And there you go. That's how easy it is to fix the 10 most common runtime exceptions in Java.